Hut 1, Hut 2, Hut 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 57, 61, 67. And Deion Sanders thought he was prime time. Mind if I call you a few other things first? To me, this one's hilarious because he's giving all the prime numbers, and that's why he's calling himself prime time when Deion Sanders' nickname is really prime time. So I just thought it was funny because prime numbers, football primes. Okay. All right, moving on. Number 2, here's a mad gab for you. Lou, quad, hive, and cock. And here's a number stumper. 90D in ARA. So good luck on those. You can put them in the box tomorrow if you watch the video tonight. And I know it's kind of late. Sorry about that. Okay, let's just talk about proof in algebra and geometry. We're continuing our proof, knowing that we have to have true statements for a proof. They need to be in logical order to be a proof. Here are some of the other things that we can use to show that statements are true. We can use addition and subtraction properties, where if we add the same thing on both sides, or if you add an angle to both sides, called addition or subtract on both sides. So you would just say addition property of equality or subtraction property of equality. We can do the same thing with multiplication. We can multiply or divide the same number on both sides, and that will make it that'll still keep it as a true statement. We did substitution today in our little task. So substitution, where you can substitute A for B if they're equal to each other, you can substitute them in any time you want to. Take out the A and put in a B anytime you want. And again, you can pause the video if I'm going too fast and then catch up. Commutative property is when you move the numbers around. So A plus B is the same as B plus A. And we could also call it symmetrical property, because if I was to draw a line straight down here, which you can't see because it's white, we'll make it black. If I was to draw a line and you were to fold the paper on that line, B would land on top of B and A would land on top of A because it would be folded. So this is called symmetrical, where one would land on top of the other. So we could also call it the symmetric property. Let's get rid of that line. Associative property we could use in geometry with angles also, but it's where you're associating numbers with different numbers. Basically, you're moving the parentheses, you're keeping the order the same. All addition, ABC, and here's ABC, but you change the grouping. B and C plus C was in the first group, and then A plus B now is in the second group. Distributive property we could use in algebra and geometry to prove things, because that is a true statement. You could do A times B is AB, and A times C is AC. Now these are 3 kind of new ones a little bit. Transitive property. Sometimes it's called the if, and then property. If A equals B and B equals C. So look at A is equaling B and C is also equaling B. That means that A has to equal C. It's almost like the law of syllogism that we talked about with the ostrich. The first one has to equal the last one because they both equal the second one. So that would be called the transitive property. Reflexive property is where one thing equals itself. It's like looking at a reflection. Reflection. So A looks in a mirror and sees A. 5 looks in a mirror and sees 5. We use this one actually a lot with triangles. When there's a common line down the middle, we say that it's equaling itself. So that's a reflection property, reflexive. And then symmetrical property we kind of talked about up here. This is symmetrical because if you draw a line and you fold it, B is a little bit next to the equal sign, and it's a little bit next to the equal sign on this side, and then A is on the outside and A is on the outside. So folding it, they would land on top of each other. So that's called symmetrical property. Moving on to, can you name the property? Alright, you try. So pause the video, see if you can fill in the blanks, and then I'll show you what they are, and see if you got them right. So do that now. Okay, welcome back. We are going to try to name the property. So x equals 4, then x times 2 equals 4 times 2. Did you say multiplication property? Because you multiplied both sides by 2. So we call that multiplication. This statement is allowed because you did multiplication property. That's why it's a true statement. This would be like in the reasons part. This would be like in the statement part. Hopefully for number 2, you put division property because you divided both sides by 5 to get b equals 2. We divided on both sides. Second one, or the third one, I mean, hopefully you put either commutative property or symmetrical. Both of them would work. Commutative property is when you move them around, so that's what you did. 1 plus 2 became 2 plus 1. But also if you drew a line straight down there, you drew a line right there and you folded it on that line, then this angle 2 would land on angle 2, angle 1 on the outside would land on angle 1 on the outside, so they would be symmetrical also. And your last one, if AB equals 3y and AB equals C, so that means that CD is equaling AB and 3y is also equaling AB, then these two, 3y and CB, have to also equal. We call that transitive property. You could also call it substitution because of the equal pieces, but transitive property would be more common there. So hopefully you got those right. Let's move on. Prove the conditional statement. Here's an algebra problem that we would use a proof for. You probably did something similar to this in Algebra 1, where sometimes the teacher would make you write down the steps on what you did. So in this statement we had our given, because that's what was given to us. It's a problem. Then what they did next was they subtracted 2x on both sides. So you could actually, write that in there. So you could put minus 2x and minus 2x. So you can see that it was subtracted on both sides. So you got 5x minus 2x here, and then these 2x's canceled out. So let's see. Now these would cancel. So you would have just 9 left. So 5x minus 2x equals 9. That was called subtraction property. Then they did distributive property backwards. The x was distributed to both, so they pulled it back out of there. Basically, you could also put combining like terms, because really they're combining like terms here. But they call it distributive property. And then they did substitution by taking out the 5 minus 2 because that equals 3. So they took out the 5 minus 2 and put in a 3. You could also say subtract, but really we want a property, so we would use substitution property. And then the last one will be a division property where you divide both sides by 3. So that's just the statements, the reasons for these statements. These reasons are why these are true statements over here. So that's just a little proof with algebra, using algebra to do a proof. And then the last one here, proving lines are perpendicular. Okay, let's see if we can prove that AC is perpendicular to DB here on the bottom. Okay, the side view of the gable of the house shows beam DB, here's the beam DB, is perpendicular to cross beam AC. If a carpenter knows that the measure of angle 1 is 40, okay, so that's 40 degrees right there, that's what it's telling us in the problem, and the measure of angle 2 equals the measure of angle 1, so that's also 40 because it says angle 1 equals angle 2, so they're both 40s. How can the carpenter find the measure of angle 3? Okay, so the definition of perpendicular line says two lines are perpendicular if they intersect to form a right angle. They intersect to form a right angle, they're perpendicular. So given is that DB is perpendicular to AC, and that means that angle ACB is a right angle, so that was in there for us. So that means that angle 1 equals angle 2, and they both equal 40. So we know that angle 2 plus angle 3 is a right angle, so that adds up to 90 degrees. That's perpendicular lines make these add up to 90 degrees. So you could actually also put definition of perpendicular lines there too. And then you took out angle 2 and you put in a 40 in its place. So we're going to call that substitution property, because angle 2 and 40, that's what it equaled. Angle 1 was 40 and angle 1 and 2 are equal. So we know that they're both going to be 40. So 40, and we put that's actually right here too. 1 and 2 equals 40. So take out 2, put in 40, and then we're going to find out if we subtract 40 on both sides, angle 3 equals 50 due to subtraction property. So it's got to be a 50-degree angle. 40 and 50 have to add up to our 90-degree angle. Alright, there are your notes for 2-6. I know they're short, so hopefully you got them all done. We'll see you guys tomorrow.